Hello, I'm from Group 12, KIG 2017. My ID number is 22001519, and today I'm going to present about problem 5 in our presentation on solving a vibrations problem using Euler's method. Now, for our problem, uh, the equation that we're going to use is a second order differential equation. So to make things easier, we're going to break it down to two different smaller equations before we get things started. So first off, let's talk about the code first. Now, the code is relatively simple. All you have to do to run this code is press the run button here. It doesn't need any input from the user. All of the values are already in the code, as you can see. And for the settings, the settings are pretty standard. It's a standard .mlx file. So that's the basics for the code itself. Now, for the code itself, the parameters, we start with our coefficients for our equation, then our initial conditions, and this is for our iterations and time step and step size. The h here is the step size, and we're going to start our iterations from 0 to 0.0005. Now this is our arrays to initialize the program. We're going to use for loop for our Euler's method, and this is for our approximate error calculations, which also coincidentally uses a for loop. Also, now to display our results, we're going to use these lines of codes. This is for the table, and this for the graphs. You might can see on the right side here that I already have them, but for the sake of demonstration, I'm going to press the run button here. And to know if the code works, usually, as you can see a few seconds earlier, this was empty before, but now it is filled with data. And if I drag this side of the bar and scroll down, you should see the results. Now, here are the results for our calculations. As you can see, the iteration starts from 0 and ends with 0.0005. Now, since we're using a really small value for our step size, the error, mind you, in percentage, would only amount to 0.013562, which is a very small percentage. Now, as you can observe here, the error it is diverging, as we can say, meaning that as iteration grows, as iteration increase, the solution itself might get less and less accurate, so bear that in mind. Here are the graph. You can see for the displacement, it will reduces against time. However, the approximate error will increase across time. So in conclusion, as iteration and time goes on, the approximate error will increase, making our solution be less and less accurate. But by the time you get your desired iterations, mind you, the error would be too small to be considered as anything significant. So I recommend you to just use the data that you have here, since the error itself is below 1%.